Hello and welcome to the final episode in this trailer turned camper conversion series. Today I'll be installing the floor as well as completing the electrical system. Starting with the floor, I'm using a 1-inch XPS foam insulation. XPS stands for extruded polystyrene. Now that basically just means it's closed cell and it's got a smooth face on both sides. And that allows a plastic layer on both sides, and that's what's giving it this added moisture barrier. One of the main reasons why I like it for the flooring is it has high compression strength, so it's perfect for walking on. So yeah, that's what I'm starting with, just cutting it to size. And once I'm happy with the fit, then I'll take it out, I'll set it on the garage floor, and then that acts as a template for the following layers. Now the next layer would be plywood. For some reason, I jumped right into the rubber flooring. First I did the rubber, then I used that as a template to cut out the plywood. After a bunch of test fits, it was time to glue it all in place. I'm using construction adhesive in spray foam form. I like it because it's easier to use than a caulk gun. It goes down really fast and it cures really fast. And then I immediately put some weight on the floor and then I started screwing it in place. Now I decided not to screw to the frame of the trailer. I'm simply screwing into the factory OSB, which was secured to the frame, so it just seemed kind of redundant to do both. Now I've mentioned before in previous videos, I always prefer pan head screws over a traditional taper head screw, if at all possible. They just offer better holding power. You can torque them down without any risk of punching that screw right through the wood. It's just going to hold on to it, especially with vibrations years down the road. It's going to continue to hold better than a taper head screw. I'm using a spade bit to recess the wood so the pan head portion of the screw won't be protruding past the surface of the wood. It's never going to be as flat as a tapered screw, but knowing I had a thick rubber floor going on top of this, I knew it didn't need to be perfect. Now, I'll be honest, this was probably overkill, probably unnecessary, but better safe than sorry. So in preparation for laying the floor down, the manufacturer recommends rolling it out ahead of time, preferably in the sun. So I cleaned the driveway the best I could, and I unrolled the flooring so that the bottom was facing up, just trying to keep it as clean as possible. I had a small gap around the perimeter of the plywood. I filled that in with a closed cell spray foam, and I left that to cure overnight. The next day, once the extra foam was removed, I was able to set the rubber flooring in the trailer and do kind of one last check, make sure the fit was good. Then it was time to start gluing it down. This flooring comes from recpro.com and they sell an adhesive with it on their website. It's really sticky stuff. It's really not that hard to put down, but it is kind of messy. So you just got to work maybe a foot or 2 feet at a time until you're all done. And then I didn't show it here, but I did put a lot of weight on it again. And then I think this was maybe a day or two later. I came back, cleaned everything up really well, and then I sealed all the edges with, you guessed it, 3M Fast Cure. And then after that, I was able to work on the threshold pieces. We got the 2 side doors and then the rear cargo door. At the rear cargo door, the factory OSB actually stuck out further towards the back than the plywood and the foam that I put on top of it. So I needed the trim to step down over both layers. So what I have here is a piece of PVC J-channel. What I needed was more of a Z or an S shape. So I took my heat gun and heated it up and actually was able to bend it over pretty easy. I was able to then put it on top of that OSB, that bottom layer, and it acted as a sort of flashing. So now when I put the aluminum trim on top of that, the subfloor will be completely protected and really sealed off from the elements. Now this trim piece is actually called stair edging and it's designed to be nailed in place. So I simply use a traditional wood countersink bit. I have one dedicated just for this sort of trim. And then I use a traditional tapered screw. And unlike earlier in the video where I wanted panhead screws, here I don't, even though that would be a lot easier. This is really the only way to get a smooth surface in this application. The next 2 doorways are a lot more straightforward. This is just carpet edging. It's aluminum, just like the stair edging, installed the same exact way. This door has a small drop, so the stair edging will work best again here. And again, I use that Fast Cure everywhere. I want to make sure everything is watertight. I want to prevent any water from getting underneath the rubber flooring where it can do a lot of damage. All right, so the floor is done. Now I'm going to move on to the electrical. Most electrical components are going to be mounted on this piece of plywood. I always recommend that you finish any exposed wood, whether it's painting, staining, or in this case, I'm just using finishing wax. It is so easy to apply and there's very little dry time, unlike painting. I'm not worried too much about warpage since I'm going to be screwing this to the wall. but I don't want the wood to delaminate due to moisture or potentially grow mold. I've got my notepad, I've come up with a game plan, I've mapped out roughly where all of the components are going to go, so now it's time to start actually laying things out on the plywood, seeing how accurate my plan was. Even though I've done several builds now, it's still kind of tricky to visualize things on paper. Sometimes you need to work in the physical space to work out all the kinks. But anyway, my goal at this point is to find the shortest wire runs with minimal wires overlapping. That's always my goal. So right now, that red box, that's the main disconnect for the battery. I'm getting ready to make a cable that's going to connect the disconnect to a battery fuse. Now I'm not going to go into every little detail as I go because this video would get crazy long, but I do think it might be helpful to some to see how I make my cables and my connections, because this is something I struggled with when I first started, finding the right tools, the right products, and especially the right technique. And this is definitely an area that you do not want to cheap out on. You have to make sure that you're sizing the wire appropriately. For every build, I always have to research. I always have to reference American Boat and Yacht Council. Blue Sea has a Circuit Wizard as well as Explorist.life. They have a super easy to use wire sizing calculator. A lot of great resources available to everyone. You just have to put in the work and research your products that you're installing, and then you can build your system appropriately. I always get my cable from batterycablesusa.com. This is not an endorsement. I just love their products. They offer great quality cable. They offer all the connectors, fast shipping, great customer service. I'll always recommend them to anyone building their own system. Here on the floor are all the tools that I use for making my cable connections. First thing I do is I place the cable next to the appropriately sized connector. I first score the sheath, and then I use my utility knife to carefully cut all the way around that sheath, being very careful not to cut into any of the copper strands of the wire itself. Then I take my channel locks and I grab a hold of that end and I carefully pry up and down. I rotate the wire, I pull up and down a couple more times, and that action is strong enough to split the insulation but not damage the wire, because we definitely don't want to cut any of the strands. They sell a couple different types of cable. One of the varieties is stiffer than the other, and this is definitely the stiffer version. Now, if you did it right, none of the wires are missing, they're not all splayed out. Even if you did everything right, it can still be a pain in the butt to get them in the connector. Obviously, you got to make sure it's the right size connector, but it's meant to be a tight fit. Now, I usually, once I get it started, I twist it a little bit as I push it on there. I just feel like that's going to have the most overlap in wires that are going to get crimped together, which is going to make the ultimate connection. Now, normally I would like that connector a little bit tighter to the insulation, but I'd rather have a little gap there than not enough in the connector itself. The little bit of wire that is exposed there will eventually be covered with heat shrink tubing. And I recommend getting the connectors off of Battery Cables USA because they're a tinned copper, so they're not going to corrode. I haven't found anything as nice on Amazon or eBay. Some auto parts stores may have connectors, but they might not go as big as 4/0. In my experience is they're usually not tinned either. The next step is crimping. This is a very inexpensive, easy to find hammer crimping tool. You can get them at Northern Tool, you can get them on Amazon or eBay, and they are very effective. They work up to 4/0 cable, which is huge. They can be mounted, but I've yet to take the time to do that. But all you have to do is hit it with a hammer 2 or 3 times and it makes a super solid connection. Now, better yet, they do make hydraulic crimpers. They do a nice uniform crimp all the way around the cable. Now, I don't have this yet, but my ideal crimper would be a bench style crimper, but they do come with a hefty price tag. So the next step is heat shrink. Again, I like the Battery Cable USA kind. They sell a very thick, durable heat shrink tube. Now, I also have some of the Amazon kinds. Some of them are okay. I haven't found any that are quite as thick. I always like to see when there's a little bit of adhesive starting to show itself at the ends. That's letting you know that the glue has softened throughout the tube and it should be good and sticky throughout. Other things to keep in mind: if the cable is bent slightly, use that to your advantage. It may not be the end of the world if you forget this, but things will go a lot smoother. This cable is also a good example. It shows how the two connectors, they might not be on the same plane. One might be rotated a little bit different from the other. Make note of that when you're doing your test fits. Even use a marker if you have to. And the last thing I'm going to mention is the hole sizes on your connectors. You want to make sure that the hole size matches the bolt that you're using. If the hole is too big, if it's bigger than the bolt, it's not going to make a good connection. It's not safe. Battery Cables USA, they have all the different hole sizes. So that's what this whole spiel is about. Buy the right cable for the load, buy the right connector for the cable, and the right connector for the bolts. I jumped over to the solar charge controller next. I think I was excited to work with these DC breakers. I've never used them before, but NEC code states that you need a breaker on both the positive and negative side when working with solar controllers. The DC breakers are mounted on what's called DIN rail. The breakers kind of lock onto the rail and they really can't move around too much. It's just a really nice system. You need a disconnect, and most cheap DC breakers or disconnects, they're not rated high enough in terms of voltage. So this is really the only way to go. All the breakers I've seen like this, even if you go with name brands like Busman or Blue Sea, they're only rated for 48 volts. Now the solar output with this trailer will approach that or maybe even exceed that. That's why I'm going with this style breaker, because it's the only one that I found that's over 48 volts. Now I'm at a point where I think I have most components on the plywood roughly where they're going to go. I'm pretty certain I'm going to have to move things around a little bit. So I put it back in the trailer with the battery and inverter charger to kind of mock things up to better visualize what kind of space I have to work with. Keep in mind, I'm going to be building a bench over all of this later in the episode. So I'm trying to leave room for extra batteries if the system is to be upgraded down the road, but I'm also trying to keep my wire runs as short as possible. So I'm definitely moving things around on the plywood to see what fits best. It's just a bit of trial and error, and then it gets to the tedious part of actually cutting all the cables, making the connections, and then I realized I still hadn't established the system ground. I always ground to the chassis, so I'm notching out the plywood and notching out the trailer's OSB to access the trailer's metal frame at the bottom of the wall. Now, to establish a solid connection point for the ground, I'm installing a rivet nut, or riv nut, also known as a threaded insert. They go by many names. In the trailer, I used a manual hand tool, very cheap, very inexpensive, but they can be tricky to use, especially in tight places, and especially if you're doing a bunch of them. So I've since picked up this pneumatic tool, which makes inserting them so fast, so easy. Both tools work, both have their strengths and weaknesses. This video just demonstrated better how a threaded rivet is installed and then how you can use a bolt to attach just about anything. So here's the threaded rivet installed in the trailer, which means I can connect the negative bus bar to the chassis. Think of this as a safety ground. Grounding to the chassis ensures that if you have a positive wire coming in contact with the chassis, it will blow the fuse, preventing further damage and preventing the trailer chassis from becoming energized. Now that should do it for all of my DC connections. The last step is to secure the battery. So I'm just making a few measurements, making sure I left enough room for the extra batteries. And now I'm going to just do a really simple system for securing the battery. I'm just taking some scrap OSB, and I purchased a cinch strap, and I'm going to put the strap underneath the OSB before I glue and screw it in place. And there you go. Super solid, not going anywhere, and easy enough to modify if the future owner wants to add more batteries. After that, I hardwired the Romex to my inverter charger, and that was pretty much all I could do, because the rest of the wiring is going to go to a distribution panel that's going to have AC and DC loads, and that's going to be placed on the bench. So next step is building the bench. Like most things, it starts by taking some measurements and coming up with a plan. I'm going to frame the bench with 1x2s and 2x2s. Then I'm going to use plywood for the sides. Before I assemble the box, I'm going to first cut out for the distribution panel as well as 2 vents. After that, I added some bracing for the bench top, and then I actually attached the bench top using a piano hinge. Oh, this is awesome. This window can open. You know, you get a nice breeze. It could be raining, you could still have it open. Yeah. This could have been a little bit deeper. That's kind of the compromise in case somebody wants to haul as much stuff as possible in the back. I put this strip here because this is the depth of maybe a cushion, a pillow, so you could still potentially open it without taking this cushion away, but also it makes it easier to have that keep open. I'll show you what it looks like inside. So you got room For 3 more batteries, you could go with a bigger battery. So the SOK brand, I kind of like their setup, very budget-friendly battery. You get a lot for your money. So they do make a 206 amp hour battery that's very similar in size. So I believe even 4 of those would fit in this space. So you could have a huge battery bank if you want to. Just screwed that to the trailer walls, screwed it to the floor. So this is for all of the AC breakers, and the DC loads are gonna go to this. So everything's gonna come right in there. Still have access to the solar controls, still easy enough access to all the shutoffs. Everything's pretty accessible still. So I'm now starting to get the distribution panel ready. I'm working on the AC side first. Instead of pushing the wire through the built-in knockouts on the back, I like using metal clamp connectors because they're actually going to hold onto the wire. They're going to minimize movement, which is key with all the vibrations in a camper. Whereas the plastic knockouts or clamps, they're actually pretty sharp. They could potentially damage the insulation and cause a lot of problems down the road. I'll go so far as to say that they shouldn't even make that as an option for an RV distribution panel. So I'm going to go ahead and get this thing mounted. I start by routing the Romex cable that is going to be feeding the distribution panel coming from the inverter charger. Next, I route the Romex that will be leaving the distribution panel and feeding the outlets. And that's it for all of the AC wiring. Now I'm moving on to the DC side. So I'm running a positive and a ground for all the DC loads that are going to be fused within this distribution panel. All of my DC loads, they've all been labeled, so I'm just simply putting on spade connectors to connect to the backside of the panel. And once all of the connections are made and all of the wires secured with clamps, now I can move to the other side. First, working on the AC side, the Romex connecting it to the neutral bar, ground bar, and breakers, then replacing the cover, labeling everything, and then I can finally put the DC fuses in. And now the system is live, so I think now would be a good time to do an overview of the system, because I know it wasn't super clear, all the components I used. So starting off from the battery, I have the positive cable going to an A&L fuse. Now that fuse is going to be dependent on the output of your battery. That is a very tried and true type of fuse that people use. Another option is they do have terminal fuses. Blue Sea makes them. There's some debate as to they're right for every application, but nearly every application should have a fuse between the battery and the bus bar. So you should have a fuse, then a shutoff, and then you can go to your positive bus bar. The bus bar is also receiving power from the solar charge controller and the charger. So the charger has a wire, you can't see it sneaking behind the battery, and it's going into this breaker and onto the positive bus bar. The solar charge controller is receiving power from the solar panels on the roof. There's going to be a positive and a negative wire from the panels. Positive and negative wires from the panels come into this dual pole breaker and they go into the charge controller. So then from the charge controller, a positive comes out and goes into a separate breaker before feeding into the positive bus bar. The negative for the charge controller, you can just see a sliver of it here. The negative bus bar is hidden down low behind this battery. For the battery monitor, in order for an inverter charger to be read accurately, the negative cable from the inverter charger has to go to the appropriate side of the shunt. The negative from the inverter charger goes to one side of the shunt. The battery negative will be on the other side of the shunt, and then that same side that the battery is connected to, another cable goes to the negative bus bar. Now, alternatively, I could have ran the negative from the battery to the bus bar directly, and then a cable would connect from the bus bar to that left side of the shunt. This wire here, it's going over the solar charge controller into another DC breaker. From there, it's running over to the distribution panel out of sight here. This DIN rail is actually behind the charge controller, and that worked out really well because this allowed me to take up less space. All of the solar breakers on one side and the breaker that feeds the distribution panel is on the other side, so it keeps it nice and organized. I required the double pole breaker for the higher voltage produced by the solar array, but for the other two breakers, I could have gone with the cheaper Busman breakers, but this was so neat and tidy and compact with how they mounted. I think this turned out great. Now, the last thing I want to mention about the bench, you can see the two white vents that I added in this episode, but if you watched previous episodes, you might remember there's an additional vent that I added previously right there. This vent was previously at the front of the trailer. It's a factory vent that I relocated for the dome fan that you see here. But I moved the factory vent to the back specifically for added ventilation for the electrical cabinet. So that's it for the electrical cabinet bench. Up here I have a couple pigtails sticking out for future USB charging, and more up top with additional lighting options as well. This would be for a potential sleeping area, an elevated bed area here. Now, I wasn't going to install the USB or bed lighting options simply because I don't know the preferences or requirements for the future owner, so that's why I left it as is. A dual zone dimming light switch for the ceiling lights. I always like having a dimmer switch, and with the 2 zones, depending on the size of the camper, it just gives you so much more lighting control. Then I've got a switch for the outside lights. I've got one on each side of the trailer. They are either motion activated or simply on and off. The button on the housing lets you switch between the 2 modes. I don't know why motion lights aren't the standard for RVs. This would be an easy upgrade for any RV, so definitely check them out. Next, I have it pre-wired for a power awning, cover over the junction box for now, and then I have the Max Air ceiling fan and remote control. It's not a terrible reach to the manual controls on the fan itself, but the ambient temperature readout on the remote is a nice feature. Next, we have the Max Air dome fan. You can just pop it open to turn it on. Also has the LED ring light, which is nice. Well, that's it for the episode, and that actually completes the build series. I found a lovely couple that was excited to take on the rest of the project to finish it how they wanted to, which is exactly what I hoped for. I learned a lot through this series. I've built other campers in the past, mostly camper vans. A trailer conversion like this brought on a whole nother set of challenges and opportunities. So it was a lot of fun. I learned a lot. I hope everyone that watched learned at least a little bit. I look forward to doing more videos on who knows what in the future. But for now, thanks again for watching, and we'll catch you next time.